Stats students, so I'm going to be going through this January 2010 paper. As always, let me know if there's anything you don't understand or anything more you'd like me to go through. So question 1, so a camera records speeds miles per hour of 15 vehicles on a motorway, and they're given us the speeds below. First question, construct a sorted stem and leaf diagram, represent these data, stem values 50, 60, blah blah blah. So to start, let's just think about our stems are going to go from 50 up to, it looks like, 80. So if we look for the 50s first, we've got 52. No more 50s, so the next, we've got 63 there, 64, 67, 68, and then in 70s we've got 71, two 72s, 73, two 75s, a 77, and an 81. Just one thing to say, oh, I've missed out loads, haven't I? As is always the way. Right. So we want a 4 here. We can't about this 5 and the 9. And then the 81. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, hopefully I've got that right. One thing to be careful of, obviously it's quite easy to make a mistake in a stem and leaf diagram. Be careful not to kind of scribble stuff out and then add them in afterwards or squeeze them in. The whole point of this is these need to be kind of nicely spaced out. So if you do make a mistake, hopefully you've done it in pencil and you can rub it out, or I'd recommend just redoing it. And then we need to remember a key. So for example, 50-2, we can say equals 52 miles per hour. So let's just double check the mark scheme. So you get a mark for the stem, a mark for the leaves, a mark for them all sorted, and by sorted they also mean nicely ordered like this, so they're all in the same columns, and then 1 mark for a key. Right, next part, write down the median and mid-range of the data. So the median's not too bad, hopefully you all know that's the middle piece of data. So because there's 15 pieces of data, 15 plus 1 divided by 2 is 8. So we want the 8th piece of data. So 1, 2, 3, 4, 5, 6, 7, 8. So our median is 72 miles per hour. The mid-range, something not in GCSE, and that is literally the highest value plus the lowest value divided by 2. So in our case, it's 52 plus 81 divided by 2, which is, I'm going to cheat because I don't have my calculator, 66.5. Okay, so it's literally 1 mark for the median, 1 mark for the mid-range. So it's the average of the highest and lowest values. So part 3, which of the median and mid-range would you recommend to measure the central tendency of the data? Briefly explain your answer. So these are one of those horrible stats questions, but I reckon you're probably allowed to use either. Now, if we look at the mid-range, that's going to be affected by outliers. So you can see this mid-range is really affected by this 52, which is quite a lot lower than the next one up. So in this case, I'd say the median's more representative because this one's been more affected by this one result. So let's see what they say. So either the median, since the mid-range is affected by that outlier, or the median, since the lack of symmetry renders the mid-range less representative. So by that, they mean that the data is more skewed towards here, which again is kind of just saying this 52 is making it more skewed. Right, so in question 2, in her purse, Catherine has 2 £5 notes, 2 £10 notes and 1 £20 note. She decides to select 2 of these notes at random to donate to a charity. The total value of these notes is denoted by the random variable x. So first of all, show that the probability x equals 10 is 0.1. So essentially we're saying show that the probability she takes out 2 notes that have a total value of £10 is 0.1. So to get £10, you'd have to select both £5 notes, and in total she's got 5 notes. So it would be 2 out of 5 times by 1 out of 5, which is, so 2 out of 5 times by 1 out of 4. So she's got to get the first £5 note, which she's got a 2 in 5 chance, and then there's 4 notes left, and only one of those is the other £5 note. So that will give you 2 over 20, which is 1/10, which is 0.1. Right, so next part, show that the probability that she takes out £30 is 0.2. So now there's different ways this can happen. So she can either get the 10, then the 20, or the 20, then the 10. So we've got to work out both of these probabilities and add them up. So first of all, 10 then the 20, she's got a 2 in 5 chance, because there's 2 £10 notes, times by 1 in 4 to get the 20. So that's going to be, once again, 0.1. And then 20 then the 10, she's got a 1 in 5 chance, times by a 2 in 4 chance, so another 0.1. If we add them up, we get 0.2. Okay. Right. Now part 2, they've given us the probability distribution of x, and they're asking us to find the expectation and variance. So this is real like bog standard S1. So you need to remember your 2 formulae. One is that the expectation of x is the sum of r times the probability x equals r. So in other words, times these all together and add them all up. So we'll be doing 10 times 0.1 plus 15 times 0.4 plus 20 times 0.1 plus 25 times 0.2 plus 30 times 0.2. And again, I'm going to cheat because I don't have a calculator. So you should get 20 for that. So we expect her to pull out £20 from her purse. Right, variance is a bit more complicated. So for the variance, we need the expectation of x squared minus our expectation of x squared. So what that means is, to do the expectation of x squared, instead of doing 10 times 0.1, 15 times 0.4, etc., we have to do each of these squared times by the probabilities. So in other words, 10 squared times 0.1 plus 15 squared times 0.4 plus ... And if you do all that, you should get 445. Right, and then we've got to take away the expectation of x, which was 20 before, and that squared. So we've got to take our 445 and take away 20 squared. So I reckon that is 45. Right, good. So on the mark scheme, first mark for doing the sum of each value times by the probability, a mark for getting the answer, which is 20. Here you get a mark for doing the sum of each outcome squared times the probability, and you need at least 3. A mark for taking away your expectation of x squared, and a final answer mark for 45. And you can see there's quite a few bits where you're allowed to follow through. Right, good. Right, question 3. In a survey, a large number of young people are asked about their exercise habits. One of these people is selected at random, and then we've got 2 events. G is the event the person goes to the gym, R is the event that this person goes running, and we're given P of G, P of R, and P of G and R, so the probability someone goes to the gym and goes running. So draw a Venn diagram showing the events G and R and fill in the probabilities corresponding to each Venn diagram. So this first part really is actually to kind of help you out, because drawing the Venn diagram will make this question a bit easier. Okay, right, so let's call this G and this R. So, and we've got to fill in all 4 regions. So to start with, we should put a little epsilon here. We can't fill in, so for example, we know the probability of G is 0.24, but that's split into these two regions. So before we can fill in either of those, we've got to know one for sure. So thankfully we know the intersection, so this area here is 0.06. So then we know 0.24 minus 0.06, this must be 0.18, and this one must be 0.07. So we've done 0.13, take away 0.06. And finally, the outside we know is 1 take away all of these 3 bits. So that will be 0.69, I want to say. Let me double check. Good. So we can see you get a mark for 2 labelled intersecting circles, not bad. A mark for 2 correct probabilities and a mark for the rest. Part 2, determine whether the events G and R are independent. So you need to remember the condition for something being 2 events being independent is that the probability of G times the probability of R has to equal the probability of G and R. So the probability of G is 0.24, the probability of R is 0.13, and we've got to decide does that equal 0.06, which we've been given, and that equals 0.0312, so it does not equal 0.06. So you need some kind of conclusion as well. So show the calculations, show that doesn't equal 0.06, so they're not independent. Right, finally, find the probability that someone runs given they go to the gym. Now there's a couple of ways of doing this. You can use the formula for conditional probability. So you might know that's the probability of R and G over the probability of G. So that would give you 0.06, which we're given, over 0.24. Sorry, 0.24. So that would be a quarter. Or another way of looking at it is, on the diagram, what's the probability someone runs given we know they go to the gym? So you can see that there again is 0.06 out of the total 0.24. So you get a mark for a numerator of 0.06, a mark for a denominator of 0.24, and then a mark for a quarter, or 0.25. Okay, on to question 4. So in a multiple choice test there are 30 questions. For each question there is a 60% chance that a randomly selected student answers correctly independently of all other questions. So we want to find the probability a randomly selected student gets a total of exactly 20 questions right. So you should hopefully notice that this is a binomial question, because you can see there's 30 trials effectively, of which there's a 60% chance of a success, 40% chance of failure. So we can call x the number of questions the student gets right, and that's going to be distributed binomially with n equal to 30 and p equal to 0.6. So you've got the formula for this in your formula books as well, with your tables. So we want the probability that x equals exactly 20. So we want that will be 30c20 times by the probability of a success to the power of the number of successes times by the probability of a failure to the power of the number of failures. And if you put that in your calculator, you should get 0.1152. So on MEI they like probabilities to 4 significant figures for some reason. Right, if 100 randomly selected students take the test, find the expected number of students who get exactly 20 questions right. So if you think about what's going on, we're taking 100 students and each of them's got a 0.1152 chance of getting 20 questions exactly correct. So the expectation would be 100 times by 0.1152, so about 11.52. Good. So that's what they've got there. And careful, remember an expectation doesn't have to be a whole number, so make sure you don't round it. Right, question 5. So my credit card has a 4-digit PIN code called a PIN. You should assume that any 4-digit number can be used from 0000 up to 9999. First of all, if I cannot remember any digits and guess my number, find the probability I guess it correctly. So if you think there, basically each digit we've got a 1 in 10 chance of getting it right. So the probability of getting all the way across is going to be, well, we've got 10 options on the first one, times by 10, times by 10, times by 10. So that's 10,000 ways, which makes sense because it goes from 0000 all up to 9,999. Right, good. In fact, my PIN consists of 4 different digits. I can remember all 4 digits but cannot remember the correct order. If I now guess my number, find the probability I guess it correctly. So if you think what's going on, let's say our PIN is, we know it contains the digits A, B, C, D, but we got no idea what order it is. So, and we've got to get all 4 correct. So if you think what's the probability we get the first number correct, well, that's going to be 1 in 4. So I've just realised part 1, we should have said 1 in 10,000 rather than, so there are 10,000 possibilities, so a 1 in 10,000 chance. So the probability we get the first digit right on this one is a quarter. Then the second one, if we've got that right, now there's 3 digits left and we need to get that one right. And then similarly we've got 2 digits left and we need to get that right. And then if we've got all these 3 right, then there's no way of getting this wrong. So that'll be 1 in 24, I want to say. So let's look at the mark scheme. So for part 1, they've done 0.1 to the power of 4, so we kind of did 10 to the power of 4 and did 1 over. Maybe you've done it the more efficient way. And part 2, 1 over 4 factorial, which is equivalent to that, 4 times 3 times 2 times 1, which is 1 in 24. Right, good. Question 6. So 3 prizes, 1 for English, 1 for French and 1 for Spanish are to be awarded to a class of 20 students. Find the number of different ways the prize can be awarded if no student may win more than 1 prize. So we've got to think of all the possible number of ways we can get this without any student getting more than 1 prize. So if we think, let's say we're awarding the English prize to start, think about the number of options we've got. There are 20 options. Then we've got to award the French prize. Now think, how many students have we got left? Well, we had 20, we've given 1 the English prize, so there's only 19 we can give the French prize. And finally the Spanish. So again, now we've only got 18 students left. So there's 20 times 19 times 18 ways, and that will give us 6,840. Good. Right, now the number of ways in which 3 prizes can be awarded if no student may win all 3 prizes. So now you're allowed to win 2 if you want. So I think the quickest way of doing this is, let's just assume a student can win all prizes and let's think how many ways that can be awarded. So now it's going to be 20 times 20 times 20 because they can win, because this student who won the English prize can win the French prize and can win the Spanish prize. So 20 times 20 times 20 is 1,000, I want to say. But we've got to eliminate all the possible ways a student can win all 3 prizes. So if we think there's 20 students, so that means there's going to be 20 ways in which a student could win all 3 prizes. So from our 8,000, we've got to take away 20. So I reckon that's 7,980. Okay, good. So you get a mark for figures minus 20, so if you're taking 20 away, and a mark for 7,980. Right, so on to question 7, which looks like a histogram. So a pear grower collects a random sample of 120 pears from his orchard. The histogram below shows lengths in millimetres of these pears. So first of all, calculate the number of pears between 90 and 100 millimetres long. So this shouldn't be too bad. This is pretty standard. So they're just showing that you understand that the frequency on a histogram is the area. So for 90 and 100, the class width is 10 and the height is 2. So that'll be 20. It's not so bad. Second question. Calculate an estimate of the mean length of the pairs. Explain why your answer is only an estimate. So first of all, remember this is the mean, it's not the median, so this isn't the kind of thing where we're trying to split the area in half. Really, we're going to have to kind of make a frequency table of sorts. So let's see, so 80 to 90, that's going to be 10 times 5.5, so that's 55. 70 to 80 goes up to 3.5, so that's going to be 35, and 10 and 1, that's going to be 10. So you might just want to double check that all the numbers add up to 120, which they do on mine, so good. Right, so this is where we're doing sum of the frequency times by the lengths over the sum of the frequency. So essentially we've got a frequency table here saying 60 to, we've got 10 pairs which are 60 to 70 millimeters, 35 pairs 70 to 80 millimeters, etc. So we're going to have to do all the midpoints times by the frequencies. So 65 times 10 plus 75 times 35 plus 85 times 55 plus 95 times 20, and then we know our frequency is 120 total frequency. So if we do that, right, so when you put that on your calculator, you should get 82.1 millimeters to 3 significant figures. And then explain why your answer is only an estimate. Well, because this is all group data, we can't give an exact value because we don't know the exact length of all the different pairs. So you get a mark for using the midpoints, a mark for the double pairs, which I assume means these things times together, and then you get a mark for 82.08, and then this is 1 mark as well. Okay, good. Right, so part 3, calculate an estimate of the standard deviation. So it's getting more and more complicated now. So we've got, it might be worth drawing out our table of midpoints and frequency. So what did I say before I cleared them? 10, 35, 55 and 20. Yep, so 10, 35, 55 and 20. So we've got to decide which formula we want to use. So I prefer using the, so we need to find SXX to start. I prefer using the sum of x squared f minus n x bar squared. So in other words, we need to do the sum of all the midpoint squared times by the frequencies, and then we could take away 120 times the mean squared, which I'm going to try and keep in my calculator. So that was, as an exact number actually, that was 985 over 12. So that was our x bar. Right, so x squared f, so I'm going to do 65 squared times 10 plus 75 squared times 35 plus 85 squared times 55 plus 95 squared times 20, and that gives me 817,000. And we've got to take away 120 times by our x bar, sorry about this, which is about, what was it, 82.1, but I'm going to use this exact answer squared, and that gives me 8,479.2. So I'm going to leave that in my calculator. Now to get the standard deviation, we're going to have to do the square root of SXX over at n minus 1, so that'll be 119. So I'm going to put the square root of answer over 119, and that gives me 8.44 to 3 significant figures. Quite a lot of work for 3 marks. Good. So you get a mark for the sum of fx squared, so they're using the same method as us. Mark for a valid attempt at SXX, so like this. and a final mark for getting to the correct answer. Okay, right, we're getting there. Right, so on to part 4. Use your answers to part 2 and 3 to investigate whether there are any outliers. So you need to know that using the kind of mean and standard deviation, anything outside either 2 standard deviations above the mean or 2 standard deviations below the mean are considered outliers. So first of all, we've got to do 82.1 at x bar plus 2 times 8.44, which gives us 98.98, so 99 really as far as we're concerned, and x bar minus 2 standard deviations should give you about 65.22. So 98.98, that's about here. So we could say there's a possibility of outliers at the kind of upper range, and then 65.22 is about, say, here. So we could say there's probably some outliers below as well. So we can never be sure because it's just group data. So all they want is the 65.2 and 98.96. So you get 1 mark for working both of those out, an answer mark for both, and then just purely for saying there are probably some outliers gets you a mark. Right, finally, part 5. Name the type of skewness of the distribution. So we can see here, you can kind of, if you draw that, we can see there's kind of a negative skew. So you've got a kind of tail going off to the left, which means it's a negative skew. Which for that 1 mark, you just literally need to write negative. Right, the last part is illustrate the data on using a cumulative frequency diagram. So in the exam, they'll probably give you the axes to draw this on. I'm not going to go through drawing this. Let's just kind of look at the mark scheme. So you get a mark for kind of drawing your table with the upper bounds. So remember, cumulative frequency always needs to be plotted with the upper bounds, and then the cumulative frequencies underneath. A mark for scales, a mark for labels. So that needs to be length as your x-axis and cumulative frequency on your y-axis. So a mark for plotting the point, so at the upper of the class boundaries, and you get a mark for joining the points with a nice smooth curve like that. Good. So that's 5 marks in total for really what's kind of not that bad a GCSE question. Okay. Right, question 8. An environmental health officer monitors the air pollution level in a city street. Each day the level of pollution is classified as low, medium or high. The probabilities of each level of pollution on a randomly chosen day are as given in this table. Right, so part 1. 3 days are chosen at random. Find the probability the pollution level is low on all 3 days. So to be low on all 3 days, it's got a half chance of being low. So it's going to be 0.5 times 0.5 times 0.5. So 0.5 cubed, which is 1/8. So 0.125 if you like. Part 2, low on at least 1 day. So what I would think here is if we work out the complement of this, so let's assume that it isn't low at all. The probability of that happening is 0.5 on each day. The probability is not low. So 1 minus 0.5 cubed. So it's kind of a coincidence that these are the same things. So that would be 1 minus an eighth, which is 7/8, which is about 0.875. Right, and the last part. Low on 1 day, medium on another day, and high on the other day. So we've just got to be careful here because we can think this can happen in any order. So it could be low, medium, high. It could be high, medium, low, etc. So first of all, let's just work out the probability of, for example, it being low, then medium, then high. So that's going to be 0.5 times 0.35 times 0.15. But we also need to know the number of ways in which that can happen. So if we think the first day we've got a choice, it can be either low, medium or high. The next day it can be then all of them apart from the one we had there. And then the final day it's going to be the remaining one. So there's kind of 6 ways in which that can be arranged. So really that's like 3 factorial. So that's going to be 6 times 0.5 times 0.35 times 0.15, which is 0.1575. So if we just look at the mark scheme, we get a mark for 1/8 there, a mark for the 7/8 here, and then a mark for, you get a mark for this. So the probability is 0.15 times 0.35 times 0.15, and a mark for timesing it by 6 or 3 factorial or whatever. Okay, good. Right, part 2 then. Right, 10 days are chosen at random. Find the probability that there are no days when the pollution level is high. And so I think now you should be hopefully recognising we're going to have to use a binomial distribution. So if you think about what x is, that's going to be the number of days the pollution level is high. So you might want to make a note of that. So there are 10 trials because we're looking at 10 days, and we'll say a success is that the pollution level is high, so 0.15. You could have phrased it as not high and then had it 0.85. It just would have made your working out a bit different for the next parts, and that's fine. Right, so part A, there are no days when the pollution level is high, so that's the probability of x equaling 0. So using the formula, that's going to be 10C0 times by 0.15 to the 0 times by 0.85 to the 10. So that makes sense because this is 1, this is 1, so it's literally all the 10 days not having a high pollution level. So it's just going to be 0.85 to the power of 10, which is 0.1969. And they like probabilities to 4 significant figures. Right, for B, there is exactly 1 day when the pollution level is high. So here we've got the probability x equals 1. And that's going to be, so again, same formula, 10C1, because there's 10 different ways of choosing 1 day from 10 days, times by 0.15 to the 1, so we want 1 success, times by 0.85 to the 9, because we want 9 kind of failures. So 10 times 0.15 times 0.85 to the power of 9 is 0.3474. Right, good. So let's just double check those. Good, so there 0.85 to the 10, so 0.1969. Here, a mark for this part of the formula, a mark for timesing it by 10, and a final mark for 0.3474. So, last part. Right, so they've saved the hypothesis test for the last question of the paper. So the environmental health officer believes that the pollution levels will be low more frequently in a different street. On 20 randomly selected days, she monitors the pollution level in the street and finds it is low on 15 occasions. So they want us to carry out a test at a 5% level to determine if there is evidence to suggest she is correct. So first of all, let's think, what does she mean by she is correct? She believes pollution levels will be low more frequently on a different street. Okay. So first of all, we need to know, so the probability it was low is 0.5. So use hypotheses. So her null hypothesis is that the probability of the pollution being low is 0.5. It hasn't changed. And her alternative hypothesis is that actually the probability of it being low is greater than a half, so it's more likely to be low, where P represents the probability of pollution level in this street is low. Explain why H1 has this form. Right, okay. So let's think about what's going on first. So our thing we're testing is n is 20, because it's 20 randomly selected days, and the probability of success was 0.5. And then we've got some data. She's found that it's low on 15 occasions. So what we're going to try and work out then is, well, what's the probability that this just happened out of randomness? And then if that's lower than 5%, that's when we'd reject the null hypothesis and say, right, so something is up, something has changed. So let's work out what's the probability that this or something even better would happen. So the probability x is greater than or equal to 15. Okay. Right, so this isn't, well, we could work this out using like our calculators, but it would take a while. It would be easier to use the tables. So we want to know the probability x is greater than or equal to 15. Now our tables are only in the form x is less than or equal to something. So we're going to have to do 1 minus the probability x is less than or equal to 14. Because we want to include 15, 16, 17, 18, 19 and 20. We're going to take away everything below that. So I have my formula book. So turn right to the back, or near the back. And then we need where n equals 20, so the very last table. Our p is 0.5, so somewhere in the middle. And we're looking for 14. So I get 0.9793. So 1 minus 0.9793, which is 0.0207. Right, good. So that's there was about a 2% chance of this happening out of just sheer probability. So we can say then, well, 0.0207 is less than 5%. Therefore, reject H0. So we're saying reject the kind of status quo because we think something different has happened. And then you need some kind of concluding sentence, which I say something like, so there is sufficient evidence to suggest that the pollution level is lower in this other street. So you need to relate it back to the actual context. And then why does H1 have this form? Well, that's because she thinks that the probability of being low is higher. So it's not a two-tailed test, it's this one-tailed test where it's getting higher. Right, so let's look at all the marks. So either probability x greater than or equals 15 needs to get 0.0207. So you get a mark for a correct probability and a mark for a comparison with 5%. Then there's this different way of using a critical region. So this is basically, you find, this different way of doing it is you find all the outcomes you could have got which would have caused you to reject the null hypothesis, which was anything from 15 to 20, and then you say 15 lies in the critical region, so sufficient evidence to reject H0. Right, so we need to say somewhere that there is sufficient evidence to reject H0, and that gets us an answer mark. And that relies on you getting both those method marks before. And then a mark for conclusion in context, what that means is something relating it back to the actual problem. So conclude there is enough evidence to indicate that the probability of low pollution levels is higher on the new street. And you need something like, you need to talk about the evidence, or enough evidence, or sufficient evidence. And you don't make any kind of really bold claims like the pollution level is definitely lower, but it's like there is enough evidence to show it. And then a final mark about H1. So it has this form, as she believes that the probability of a low pollution level is greater in this street. Right, good. So I hope you found that useful, and let me know if you have any requests or any mistakes I've made. Thanks.